Hello, everyone. Thank you for joining me today with Notes with Mr. Jankowski. Today we have page 77 that we're going to cover. This is involving lessons 11.2 and 11.3, solving equations. So this week we're going to be solving equations instead of just evaluating expressions. So I'm going to zoom in so you can see a little better. Beginning of our page here on page 77, we have the definition for our first words, inverse operations. Now, inverse operations, according to our book, are operations that undo each other. For example, addition undoes subtraction, and subtraction undoes addition. Likewise, multiplication is the inverse of division. Multiplication undoes division, and division undoes multiplication. So I'm going to write over here on the side here for our example, inverse operations. And I'm going to put our first two, which is plus and minus. Addition is the inverse of subtraction. And then we also have multiplication is the inverse of division. You could also say that subtraction is the inverse of addition, and division is the inverse of multiplication. They are opposite operations. Our next definition here, vocabulary, is using addition when solving equations. And our definition or example from the book we have here is the addition property of equality. The addition property of equality says you can add the same number to both sides of an equation, and the two sides will remain equal. So remember, when you're taking notes with me, since this is a video, you can pause the video, rewind it, start over, stop it and come back later and finish it up. So don't feel stressed to go too quickly. When writing this down, I want you to take good notes so that you can use these notes on the quiz. Our example here, we have y minus 21 equals 18. And we have this subtraction operation here. Now I know that the inverse operation of subtraction is addition. So what I can do is I can add 21 to both sides of this equation. The addition property of equality says that I can add the same number to both sides of the equation and it's going to remain equal. Nothing's going to change. So I can do that. I can add 21 to this side of the equation and I can add 21 to this side of the equation. And you can look at this. Sometimes teachers draw a line and they say this is the barrier between the equations, right? Whatever you do to one side, you have to do to the other side of the equal sign. So I'm going to take that out. I just want that there wanted to show you that there. Sometimes teachers like to do that. I just wanted to show you that we are adding 21 to both sides. And what's that's going to do is that's going to eliminate these 21s. Negative 21 plus 21 turns out to be 0. So those can be crossed out. And we're left with just y by itself on this side of the equation. Then we have 18 plus 21 that we need to add. I'm going to do that on the side here where I can show my work. I'm going to line up the place values. 8 plus 1 is 9. 1 plus 2 is 3. So y equals 39. Let's take a look at the next example. Using subtraction to solve an equation. Again, we have another property. This time we have the subtraction property of equality. And the subtraction property of equality says you can subtract the same number from both sides of an equation and the two sides will remain equal. Same as what we did above, except this time we're going to be using subtraction instead of addition. So we have a plus 15 equals 26. I want to get this a by itself. That's my goal. If I can get a by itself, it's going to tell me what it equals. So I know the inverse operation of addition is subtraction. I'm going to subtract 15 from both sides of this equation. By doing that, 15 minus 15, that equals 0. I can just cross that out. I'll have a left over on that side. And then I still have to solve 26 minus 15. So I'll do that over here. 6 minus 5 is 1. 2 minus 1 is 1. So a equals 11. Okay, let's move on to multiplication. Multiplication has its own property, of course. The multiplication property of equality. You can multiply both sides of an equation by the same number, and the two sides will remain equal. So this comes in handy when you have a division operation inside of your equation, because of course the inverse operation of division is multiplication. So I'm going to use red here, I think. And what I'm going to do to get r by itself in this example is I'm going to multiply by 2 on both sides of the equation. This is r divided by 2, so to get rid of this 2, I'm going to multiply by 2. Now, to show you how that works on the side, this is r2, or r divided by 2, rather, sorry, times 2 is what I'm doing here. And I'm also doing multiplying by 2 on the other side to keep it balanced. But to solve this, 2 as a whole number is the same as 2 over 1 as a fraction. So when I multiply these two fractions, I get r times 2, which is 2r. And I get 2 times 1, which is 2. Now the thing is, 2 over 2 is the same as 1, so I'm left with just r by itself. So what I have here, these 2's get eliminated essentially. And I'm left with r by itself. But I still have to do 15 times 2. So I'm going to do that over here. 15 times 2. A lot of you could do this in your head, but working it out on paper is not a bad thing either. 2 times 5 is 10. Carry the 1. 2 times 1 is 2 plus 1 is 3. So r equals 30. Now, if I went quickly there, remember, you can pause this and go back. And we'll be practicing this type of solution finding using multiplication quite a bit, solving for these equations. So let's take a look at the next one, division. And of course, division has its own property of equality. We have the division property of equality, which states you can divide both sides of an equation by the same non-zero number, and the two sides will remain equal. We're going to need to do that here because our example has 9 times a equals 54. So to solve this, I need to get a by itself. And according to the division property of equality, I can divide both sides by the same non-zero number. So to get a by itself, what I'm going to do here is divide this side by 9. And I'm going to have to divide this side by 9 as well. Now 9 over 9 is the same as 1. So 9 divided by 9 is 1. I'm left with just a by itself on this side, essentially. I still have to divide 54 divided by 9, though. And I'm going to do that over here. I'm going to put 54 inside the house. 9 outside. And how many 9s can I pull out of 5? I can't pull out any. 9 goes into 5 0 times. So now I'm going to go over to 54. How many times does 9 go into 54? Well, if I'm not sure off the top of my head, I could take a guess and say, well, 9 times 5 is 45. 9 times 6 is 54. So 6 goes here. 9 times 6 is 54. 54 minus 54 is 0. I have no remainder. A equals 6. Now, down at the very bottom, we have graphing solutions. And I'm going to give you an example for that too. And here we have the example 2 equals x minus 3. We have a space where x is supposed to equal a number, and then we have a place for us to graph that on the number line. So we're solving for x. I'm going to rewrite this as 2 equals x minus 3. I'm getting that from over here. I see the subtraction operation in our equation, and I know I want to get x by itself. So to eliminate this 3 on this side of the equation, I'm going to add 3 to both sides. Minus 3 plus 3, that eliminates. And I'm left with just x equals 2 plus 3, which of course is 5. In my answer, I can put x equals 5. And then to graph it, I'll just find 5, positive 5 on the number line and place a point, place a dot. Okay, there are a couple more examples I want to give you here on this page. So I'm going to zoom out, scroll up, and take a look at what's covered up over here on this side. You'll see this type of example a few times in the book. They like this one, apparently, which means you'll probably see it on tests and quizzes as well. So it says, write and solve an equation to find the measure of the unknown angle. Tell what the variable represents. Okay, so we have 45 degrees, we have x, and then we have this straight line underneath. Now, they don't tell you this in the problem, but this is 45 degrees. We don't know what that angle is. The entire angle of a flat line is 180 degrees. That's something that we need to know before we're able to solve this problem. So if I was to make this as an equation, I could write down, I'll still use green, x is our variable. X is the angle we are missing, plus 45 degrees equals 180 degrees. The total. So I see an addition operation here. Of course, I'm going to have to use the inverse of that to get rid of this 45 degrees. So subtract 45 degrees from both sides. These get eliminated because 45 minus 45, of course, is 0. I'm left with x all by itself. And then 180 minus 45 is what I have to work out. I'm going to line up the decimals, rather the place value. No decimals in this case. 0 minus 5, I can't do that. Going to borrow from the 8, make that a 7. 10 minus 5 is 5. 7 minus 4 is 3. 1 minus 0 is 1. So x is 135 degrees. That's the angle here. So tell what the variable represents. X equals 135 degrees. That's what the variable represents. The missing angle. And then there's one other problem I want to work out. It's very similar to the one we just did, except it's a different scenario. I'm going to zoom in a little further. Okay, so it says Britta And if you're looking at these examples and you don't have space to write on your page, there are extra pages in the back of your math notebook. You can also write it down on a separate piece of paper. Just watch and see how this is done and refer back to this video if you need help on some of the problems in your homework or your independent practice. But on this problem, it says Britta withdrew $225 from her bank account. After her withdrawal, there was $548 left in her account. How much money did Britta have in her account before the withdrawal? Looking at this problem, I can already see some numbers here. $225, $548. Looking at clue words, we've got the word withdrawal. And when I see that, that means like taking money out of your account. The operation for that would be subtraction. And then after her withdrawal, this might be a clue word for equals. So if I was to write this equation, I'd probably write it like this. X, the amount that was in her account originally, minus $225 equals $548. So let's solve for X and see if we can figure out how much money she had in her account before she withdrew $225. I see subtraction as the operation. We're going to add then to both sides to get X by itself. The inverse operation of subtraction is addition. So add $225 to both sides. Minus $225 plus $225, well, that works out to nothing. To 0. So we have X all by itself equals 548 plus 225. I'm going to do that on the side. Lining up my place values. 5 plus 8, of course, is 13. Carry the 1. 1 plus 4 is 5, plus 2 is 7. 5 plus 2 is 7. So X is $773. So Britta, to answer this question fully, had $773 in her account before the withdrawal. And there's another A there, but that's okay. So ladies and gentlemen, thank you so much for watching today. Remember, if you want to watch this again, it's a video you can rewind, you can pause, you can fast forward, skip ahead. But please take good notes. You can use all of your notes on the quiz in my class. And if you take good notes, you're more likely to use them. So thank you for taking notes with me today, and I'll see you in the next one.